This lesson is going to be looking at scientific notation. Scientific notation, by definition, is a number that is between 1 and 10 multiplied by a power of 10. So if you look at the two numbers written below, the first one is an example of a number written in scientific notation because it has 2 and 34 hundredths, which is between 1 and 10, times 10 to the fifth power, which is multiplied by a power of 10. The second one is not in scientific notation because I have 23 and 4 tenths as my number, and that number is not between 1 and 10. Now, to convert a scientific notation number into standard form is just the regular version of the number. So if I have 2 and 34 hundredths, 2 and 34 hundredths, I want to take my decimal, which is right now between the 2 and the 3, and because my exponent is positive, I want to move my decimal 5 spaces to the right. So I'm going to go 1, 2, 3, 4, 5. Now, because these 3 extra spaces are empty, I'm going to fill them in with zeros. So my number in standard form is 2, 3, 4, 0, 0, 0. Now, because the exponent is positive, that makes this a very large number. When you're talking about very large numbers, there's a way to read them quickly, and that way is by putting commas in. And if you recall, commas start from the very end, and they go in every 3 numbers to the left. So after the first set of 3 zeros, I should have a comma. So by having that comma in there, we should be able to see very quickly that that number really is 234,000. What happens if you have a negative exponent? Okay, the negative exponent, in order to make the number into standard form, takes the decimal. So my decimal right now is between the 3 and the 1. But because it's negative, that means it's a really small number, so it moves my decimal that many spaces to the left. So because my exponent is negative 3, I'm going 3 spaces to the left with my decimal. So I'm going once, twice, 3 times. Now my decimal's out here, and then I have 2 spaces, so I'm filling those in with a 0. So I have my decimal point, and then I have 0, 0, 3, 1. So I'm looking at 31 ten-thousandths as my decimal. When they are small numbers in decimal form like that, the decimal's out front, but there is no need to put in commas. Now, if you want to write a number in scientific notation, so you're starting off with either a very large number or a very small number in standard form, in order to put a number in scientific notation, you have to rewrite any significant digits. So when significant digits, it's any digit that's not a 0. Significant is another word that means important, right? So in order for me to do that, though, I have to remember the definition of scientific notation. The definition starts off by saying it has to be a number between 1 and 10. So if we're looking at that first number, we're looking at it as being 8,200,000,000,000. Now that's a very large number. So when you have a whole number, your decimal always starts off here in the back. And then I need to make it so that it's between a number that's between 1 and 10. So I need to move my decimal in to the number until I get a number that's between 1 and 10. So now if I stop here, I'm at 8,200. That's still not. If I move it one more, I'm at 820. That's still not. Move it one more, I'm at 82. That's still not. So I need to move it one more time, and I'm at 8.2 or 8 2/10, which is a number that's between 1 and 10. So my significant digits are 8 2/10. Then it's always going to be multiplied by 10, so it's going to be 8 2/10 times 10. It's times 10 because our place values or our system goes in powers of 10. So for example, it's the ones place, and the tens place, and the hundreds, then the thousands. Those are all powers of 10. So it's always going to be times 10. And then the exponent that you put up here on the 10 is how many times we moved our decimal. So we moved our decimal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times. So I would have times 10 to the 12th power. So that number now is between 1 and 10. It's being multiplied by a power of 10, so it is now written in scientific notation. So if we're looking at the next example is a really small number because you notice the decimal is out front. So in order to have my significant digits, I have to move my decimal in until the number is between 1 and 10. So right now I'm looking at 278 thousandths. If I move it one more time over in between the 2 and the 7, I'm looking at 2.78 or 2 and 78 hundredths. 2 point anything is a number between 1 and 10. So my significant digits are 2.78. Then it's going to be multiplied by a power of 10. And then my exponent that goes here on the 10 is how many times we moved our decimal. So we moved it once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times. So we moved it 8 times, but because it's a small number, that 8 has to be negative because that implies that we're looking at a very small decimal versus a very large number like the one on the left.